Okay, so we're going to look at more examples of the parametric equation. We did h plus r cosine theta. Okay, so next one, this is the example what? 11. So let's look at example 12. So we look at the ellipse. Okay, so x equals h plus a cosine theta, y equals k plus b sine theta. Okay, so we would like to find the rectangle equation for this parametric equation. What do we do? We do x minus h over a equals cosine theta, and then this one you got y minus k over b equals sine theta. Since cosine theta squared plus sine theta squared equals 1, so we will have x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, and h. Okay, so let's look at continue. I think we did this one yesterday. X equals h plus r cosine theta, y equals k plus r sine theta is the same as this. Alright, so one more next example is the hyperbola. If I give you x equals h plus a secant theta and y equals k plus b tangent theta. Okay, so we're going to use the formula secant theta square equals tangent theta square plus 1, which means secant theta square minus tangent theta square equals 1. Okay, so now I would like you to try this one by yourself. Okay, see if you can work it out. Alright, so we got x minus h over a. From this one, you got x minus h over a equals secant theta. So we can square this minus y minus k square over b square equals 1. So this is going to be a a hyperbola at center at this hyperbola at center at h and k. Okay, and we have the center at hk, and the a and b is the major. A is the transverse axis, so we got c squared equals a squared plus b squared. This is the parametric equation for hyperbola. All right, so continue. Let's look at find parametric equations. Basically, previously I give you the parametric equation and ask you to find the rectangle equation. So right now, I give you the condition, ask you to find the parametric equation based on what we've learned yesterday. So line pass through 0, 0, 4, negative 7. Okay, so yesterday we've learned that the parametric equation for a line is right here, is this one. Okay, is this one, is right here. So x equals x1 plus t times x2 minus x1. Y equals y1 plus t2 y2 minus y1. So here, the parametric equation for x equals x1 is 0 plus t times the change of x is 4 minus 0. So y equals, starting from 0, the change of y is t times negative 7 minus 0. So the parametric equation is going to be x equals 4t, y equals negative 7t. Okay. Second one. Find the line pass through 1, 4, 5, negative 2. Okay, so the parametric equation for this one is x start from 1. So it's 1 plus the change of x is 5 minus 1 is 4, and the ratio is t. Okay, we don't know what t is, but that's the change of x. Okay, there is a t rate for that change of x. So 5 minus 1 is the change of x, and the t is the ratio. Okay, so a function of t. Now, y starting from 4 plus the change of y is negative 2 minus 4. Negative 2 minus 4t. So we got the parametric equation is x equals 1 plus 4t. And the y equals 4 minus 60. So starting from one point, go to another point. You have change of x multiplied by t plus the starting point. Change of y, and starting from this point, y value, and is negative 6 on the change of y multiplied by t. That's it. Okay, it's pretty simple, right? So next one, how about circle center at negative 6, 2, r equals 4. Okay, write the parametric equation for this one. For circle center at negative 6, 2, r equals 4. So I'll give you 2 minutes to write down this equation. You can refer to the yesterday's work. We did give you the parametric equation for circle. You can refer back to yesterday's work and write down the parametric equation. Okay, are you done? Alright, I'm going to call a student here, see if he can tell me. Okay, Taylor, could you please tell me what you got?
X plus 6 squared plus y minus 2 squared equals 16.
Alright, that's the parametric equation. That's perfect. X plus 6 square over, X plus 6 square plus y minus 2 square equals 16. That's the rectangle equation. That's perfect. So how about the parametric equation?
Would the x be equal 4 cosine theta?
Yep, but the center is negative 6, so it's negative 6 plus 4 cosine theta. Perfect. Okay, because center is negative 6, so basically shift the center to negative 6. So x is shift to negative 6, starting from negative 6 plus 4 cosine theta. So basically, you look at the point is negative 6, 2, which is basically here. If you draw a circle, it's pretty much like here. And this is negative 6 and 2. X direction is negative 6, and then 4 cosine theta is starting from this point. So it's negative 6 plus 4 cosine theta. How about y value?
2 plus 4 sine theta.
Very good. Perfect. Thank you very much. So 2 plus 4 sine theta. Alright. So next one. Circle center at 3, 1 and radius, which is 2. R equals 2. Okay. I'll give you 1 minute. Alright, so the parametric equation for this one, Matthew, could you please tell me what this one is? So I have to save, I need to call a student here.
So it would be, the rectangular equation would be x minus 3 squared plus y minus 1 squared equals 2 squared. And so the x would be x equals 3 plus 2 cosine theta, and y would be 1 plus 2 sin theta.
Very good, thank you, perfect, thank you very much, Matthew. Y equals 1 plus 2 sine theta. That's very good. Okay, so next, I want you to find other parametric equation for vertices, positive, negative 10, 0. And a foci is positive, negative 8, and 0. And center at 0, 0. Find the hyperbola for this one. No, find the ellipse for this one. Find the parametric equation for the ellipse given this condition. For this given condition. Okay, I give you 1 minute to work on this one. The first example we covered today is this one. You can use the first example we did today. Okay, so this one, I'm going to do this one with you together. So first we got a vertices, it's positive, negative 10. We draw the picture. Center at 0, 0. Center at 0, 0. So x starting from 0, y start from 0, plus. So center at 0, 0. Then the vertices is 10, 0, 10, 0, negative 10, 0. And the foci is 8, 0, and negative 8, 0. So you get the other side, this one is going to be 6. Because c squared equals a squared minus b squared. Since c equals 8, and a equals 10. So we got b equals 6. Okay, since a equals 10, so x equals 10, 0 plus 10 times cosine theta. Y equals 0 starting from 0 plus, b is 6, so it's 6 sine theta. Okay, so that's your parametric equation for this ellipse. And next example, find the ellipse. Vertices it's 4 and 7 and 4 negative 3, and foci is 4 and 5 and 4 negative 1. And the center is, you can see it's 4, 4, so center x value is 4. Y value is 7, negative 3, center is 3 plus 7 plus negative 3 is 4 divided by 2, so center is 4, 2. So now I want you to write down the parametric equation for this one. I'll give you 1 minute, I'm going to call a student. Okay. So right here, I'm going to call student. X equals what? Y equals what? I'll call student here. Zhijian, could you please tell me? Okay, so you put the center at 4, 2. Center is 4, 1, 2, 3, 4, and it's 4, 2 is starting from this point. And basically, the formula is x equals h plus a cosine theta, and y equals k plus b sine theta. And the function is going to be x minus h squared over a squared plus y minus k squared over b squared. So it's very obvious x starting from the center, which is 4, y starting from the 2, okay, and x start from the center here and go a cosine theta. So what you need to find out is find out a and find out b. So Jen, could you please tell me what is a? Oh wait, I can ask you what is b actually. So since the vertices is 4, 7, 4, negative 7. So this is a 4, negative 3 here, and the top is 4, 7. So if you draw the picture, you can tell me what is the vertical length. What's the major axis? So this is 7, this is negative 3. The total length is 10. So half of it is 5. And it is y direction. So it's vertical. So it's 5 sine theta this way. Okay. So now can you tell me what is x direction? What is this? This is 8 because you got the a equals, because you got this is 10. Okay, so a equals 10. For this one, I have to do a from here, but it's okay. Actually, you tell this is 10. The c equals 6 from 5 to negative 1. C equals 6. Okay, the longest one you can do a equals 10. So b equals 8. So this is 8. The length is 8. So x direction is 8. Half of it is 4. So it's 4 cosine theta. Does it make sense? Okay. You find the length in the x direction. Follow the length, the axis, major axis, y direction or x direction. Find the length, and it's just the starting from the center. Okay. So for this one, actually, I should put the other one. Put the x minus b squared, because the major axis is major axis is y direction. Okay, so 7 hyperbola. If I give you vertices, it's positive, negative 4, 0, and I give you foci, it's positive, negative 5, 0, and the center at 0, 0. Find the parametric equation for the hyperbola. Okay, so the hyperbola parametric equation, you refer it back to the secant. Where's the second one? Refer back to the one I gave you today. I think it's one. Okay, this one. Example 13 here, hyperbola. Okay, refer to this one. See if you can find the hyperbola for this one. Okay, I'll give you 2 minutes to work on this one. Alright. So I will call student here. Travis, could you please tell me what you got for this one?
I got x equals 0 plus 8 secant theta.
8? Okay, 0 plus what secant theta? 4, 8.
4.
Okay, so y equals?
That's going to be 0 plus... I'm not sure what EG is.
Alright, so now I can tell you the C equals 5 and A equals 4 and B equals what? Okay, so C squared equals 25, A squared equals 16, so B squared equals 9, B equals 3. Make sense? And so it's going to be 3 tan theta. Okay, so this is a hyperbola. You have the center, you have A secant theta, 0 plus B tan theta. Okay, so once you know A and B, it's much easier. Once you know the A, you can write it out. Once you know the B, you can write the Y direction. Alright. So next one, we're going to look at the a smooth curve. Definition of smooth curve. Okay. So if a curve C represented by x equals ft and y equals gt. So basically we have a function, a parametric equation represented by t. And this curve is called smooth. What's the meaning of smooth? Continuous. Okay, kind of, it's even more straight than continuous. So because smooth is more strict than continuous, this is continuous. This one is continuous, but it's not smooth. You see, this point is continuous, it's connected, but it's not smooth. Okay, smooth is another way to say if it's smooth, you can take a derivative. Okay, so if f prime and g prime are continuous, it must be continuous for sure. On I, and not simultaneously zero. So if the f and g, if the both prime are 0, but not simultaneously goes to 0, okay, except at the endpoint, because the endpoint, okay, it does not matter too much, except possibly at endpoint. Okay, so that's the definition of a smooth curve. Okay, so a curve is called piecewise smooth. Piecewise function means it's pieces, okay, but it's smooth at one piece, smooth at another piece. So it's piecewise. It's called piecewise smooth if it is smooth on each subinterval of some partition of I. Okay, for example, if you have something like this, it's smooth at this. Okay, it's smooth here, but not this point, but not this point, but not this point. Okay, it's not smooth this point because this one is a sharp change here. Okay, so sometimes you may have the piecewise like this, going like this, like this. Okay, it's smooth on this half circle, but not this point, not this point, not this point. It's not smooth. Okay, so it's piecewise smooth. All right. A point P on the circumference of a circle of radius okay, a rolling along street line in a plane such a curve is called cycloid. Okay, so we're going to look at an example of what is a cycloid. For example, if I give you x equals 2 theta minus sine theta, and y equals 2 times 1 minus cosine theta. Okay, this parametric equation is a cycloid. Cycloid is like this. Okay. Okay, you wrote as the circle rolled along this circumference is the circumference point rolled a straight line. Okay, basically have one point on the circle. For example, this point. You roll a circle. You roll this circle on this straight line, and this point is going from here, 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 here. You roll it. The highest point is going to be just the circle, the highest point here, and you roll over to here. So you roll this point is a P, right? This point. When you roll it, it changes the position, okay? And you roll it, it goes up again. So if you roll this circle, this P changes the trace of this P, okay? The trace of this P point. This point P at the circle goes to here or goes to here. So this P point is P, this is P. The same point P, if you roll this circle, it has a trace, it has a line like this. And this is called a cycloid. Does that make sense? Okay. So next we look at this cycloid. So what point is not smooth? Now we look at this function. We take the derivative on f theta. Basically is the x function. Okay, fx equals 2 times theta times 2 sine theta. Take the derivative is 2 minus cosine theta. Derivative theta is 1, derivative theta is cosine. Sine, derivative sine is cosine. So g prime, the derivative g is 2, derivative 2 is 0, derivative cosine is 2 sine. Negative cosine is negative sine, so it's going to be 2 times sine theta. When both of them equal 0, then that's the point which the function is not smooth. Let's look at this one. So f prime of theta equals 2 minus cosine theta equals 0. Oh, I forgot a 2. because you multiply it, you got 2. This is 2 theta minus 2 sine theta. So take the derivative is 2, take a derivative is 2 cosine. So solve this one, you got a cosine theta equals 1. Solve this one, you got a sine theta equals 0. Okay, so these two together give you theta equals 2n pi. Okay, n equals 0, 1, 2. Okay, the cosine theta equals 1, theta equals 2 pi. Theta equals 0, this one theta equals n pi. 0 pi, 2 pi, 3 pi, 4 pi. This one theta equal cosine theta equals 1 is theta equals 2n pi. So together it's just a theta equals 2n pi. Okay, so we can tell that when theta equals 2n pi, the function is not smooth. When you look at this, you roll this circle, roll this circle. Okay, roll this ring. You can see the ring or circle. When you roll this, you're starting from here to here. You roll a whole round, a whole like a circumference circle, 360 degree. It goes back to their original point. So at every 2 pi, you go back to its original point and you roll it over again. So that's why theta equals 2n pi is not smooth, because P is starting from here. And you roll here, it goes, if your P goes to here, it rolls it goes back to the point, this point again. I think it goes after 360 degree, it goes back to this shape again. So from here to here is you roll 2 pi, roll 360 degree, roll a circumference circle, it goes back to original point. So theta equals 2n pi. This cycloid or cycloid function is not smooth at this point. Another 2 pi goes back to the original point again. Okay. So that's actually the row is on the top of this line. You cannot go to the bottom. Okay. So that's how you look at the cycloid function. You probably have one. I didn't look at the homework. You probably have one of the cycloid you probably practice, but most of the problems it's going to be, I give you the condition, you can write the parametric equation. I give you the parametric equation, you can write down rectangle equation. That's very important. Okay, so now we introduced the parametric equation, but we have not done anything about the calculus part. Parametric equation, we did it, but we have not done anything of the calculus. And the calculus of the parametric equation is going to be what? Derivative and the antiderivative. So why do we need to learn the parametric equation? You may say, why do I need to learn this? To me, it seems like it's not really useful. And why do I change two equations into two, like x and y, into one function of t? Why do I need to do that? Like if I have a dy over dy as another function, x another function, now I have two functions. Previously I only have one function. Why do I need to do that? Okay, so in the next one we're going to look at the parametric equation and calculus. We're going to look at the derivative and antiderivative parametric equation. Then we're going to look at the applications, why we need to learn this. It's much simpler if you have the parametric equation for the area of the curve. For example, in the previous chapter 7, we learned we need the length of the arc length, the area of surface area, like all of those chapter 7 things, chapter 7 applications. If you use parametric equation, it's much simpler. Okay. Let's look at 10.3, which is parametric equation. And calculus. Okay. The first theorem is the derivative. we want to look at, we have to do so many parametric equations. We did a line, the parametric equation for a line, for a circle, for a ellipse, for a hyperbola, for a parabola, okay, for a quadratic equation, for a cubic equation. But I have never done any of derivatives except this one here. But now we'll look at the derivative of the parametric equation, how we're going to take the derivatives. Okay, so if a smooth curve C is given by the equation x equals ft, y equals g over t, and then the slope of C at x and y is dy over dx. The slope at one point, right, is dy over dx. Slope of tangent line is, the slope of a tangent line is the derivative. Dy over dx equals dy over dt over dx over dt. And here dx over dt cannot be 0 because it's the denominator. Okay. So let's look at an example. Find the dy over dx for the curve given by x equals sine theta square, y equals cosine theta square. Okay, so now I want to find the derivative dy over dx. So dy over dx, so this one is dy over d theta, dx over d theta. Why it's like that? You can do a short proof. Dy over dt keep changing flip. So keep the first one, change the division into multiplication. Multiply by reverse it is dt over dx. This to cancel it out. So this one give you dy over dx. That makes sense, right? So this one dux dy of dt over dx of dt, the dt cancel out. You reverse it, keep changing flip. So you got dy over dx. That's just a short proof that y is like that. So dy over d theta for the first one, derivative of cosine theta square is 2 cosine theta. Derivative of cosine is sine theta, and with the negative sign. Derivative dx of d theta is 2 sine theta. Derivative sine is cosine. First power, then the base. So cosine cancel out, sine cancel, 2 cancel, but I have a negative sign remain, so it's negative 1. Okay? So now I got the derivative is dy over dx equals negative 1, which is a slope. Alright, so next one, I would like to ask you, student, what is the equation for this one? Can you tell me what is the equation of this one? What's the rectangle equation of this parametric equation? Can anyone tell me? Maybe I can call a student here. Lacey, could you please tell me what is the parametric equation of this one? Okay, I'm gonna ask another student. If you can tell me what's the parametric equation of this one. Joshua. Very good. The rectangle equation for this one, because cosine theta square plus sine theta square equals 1. So the rectangle equation is just x equals plus y equals 1. Look at this one. You can change this equation, change this parametric equation into y equals negative x plus 1. What is the slope? Negative 1. Do you see that? Okay. So dy over dx is the slope on, okay, then it's going to be negative 1. So next one. Find dy over dx given example 2. Find dy over dx if x equals t squared and y equals 7 minus 60. The slope of the tangent line. Okay, I'll give you 1 minute to practice this on by yourself. Okay, so now I'm going to call a student here. If you can tell me what's the dy over dx. Okay. I'm going to call a student here. Look, could you please tell me what's the dy of dx here?
It will be negative 6 over 2t.
Okay, yes. The dy of dt is negative 6. The dx of dt is 2t. Perfect. So simplify this is negative 3 over t. Okay. Very good, everyone. And today we did introduce the derivative of the parametric equation. So tomorrow we're going to look at more examples and the second derivatives and applications of the parametric equations. Okay, I will see you tomorrow. Thank you very much.